At the moment, the population of the Earth is approximately 7.5 billion people. On average, every person produces around 400 kilograms of waste per year. On the total, the humankind produces 3 billion tons of waste per year. On the total, the humankind produces 3 billion kilograms of waste per year. The United Nations forecast the population of the planet to approach 9 billion people by the year 2050. The volume of waste will grow accordingly. Around 150 million people are living in our country. On average, we produce 70 million tons of household waste per year, and this figure is growing. The waste disposal infrastructure often fails to process the increasing volume of garbage. The wastes accumulate around our cities, threatening the environment, creating public discontent and massive protests around the landfill sites. Does it mean that the waste problem is unsolvable? Or is there a chance? Let us model a waste handling infrastructure. A pneumatic system for transporting wastes to the recycling facilities needs to be included in the new house design. The existing houses can be equipped with special platforms with smart garbage bins. With a card or a mobile app, the bin identifies the user and indicates the limit available. The user does not need to separate the garbage on his own. He places the garbage back in the bin and the scanner begins the checking process. If any items forbidden for transportation are found, the device issues a warning and requests to settle the issue. If the user refuses to do so, the bin does not accept the garbage and the system issues a fine. If no forbidden items are found, the bin crushes the waste in a shredder and sends them to recycling through the pneumatic transportation arteries. From remote settlements and hard-to-access places, the wastes are removed with motor vehicles. Liquid and solid industrial household wastes from the cities, adjustment territories, companies and animal farms are transported to the municipal filtering plants. There is no need to assign a land parcel for construction, as the facility may stand on the former sludge piles near the filtering facilities. Liquid wastes with the water content exceeding 98% are supplied to the dehydration workshop of the filtering facility. The dried material with a humidity of 70% is referred to as keg. After that, the water contained in keg is separated in a separating unit to produce sludge with the water content of 30%. The water content of solid waste is 60%. With the innovative methods of air, magnetic and ballistic separation and controller robots, glass and reinforced concrete items are separated from the general mass of wastes. The found glass and reinforced concrete items can be sold and reused. Solid wastes go through a shredder cascade to make fractions from 1 meter to 50 millimeters and to dry. The output material is crushed in knife and hammer mills to the fractions from 50 millimeters to 5 millimeters. Solid and liquid wastes are mixed. The water content of the material is reduced to 40%. The excessive heat produced by the line is applied to dry the material to reach the water content of 10%. The fine and dried material is supplied to the instant destruction reactor through a sealed system with no oxygen access, where it reacts with turbulent hot gas streams to be transformed into synthesized gas in less than a second. Due to the instant condensation, the synthesized gas is separated into useful gaseous and liquid high-calorie fuels. The oxygen-free destruction method produces from 5 to 12% of technical carbon. Based on the chemical composition analysis, the program decides whether the technical carbon should be sent to the combined steam and gas activation for sorbent production or to the construction materials filling production. In the absence of oxygen, dioxins and fluorides are not produced. All exhaust gases are supplied to the shock-cooled annealing chamber, after which the corona discharge is applied. All these operations comply with the current environmental regulations. Energy conversion efficiency. The high-speed conversion from the solid to the gaseous state determines the low energy consumption of the synthesis process. Therefore, the energy balance of the procedure remains positive. From 1 ton of pretreated raw material, up to 1 megawatt of electric and heat energy can be produced. From this moment, we can consider the waste recycling process as a process of energy generation with a low production cost. The released fuel is used for electric and heat energy generation with gas turbines and carbonaceous cells. Unlike combustion engines, with a maximum energy conversion efficiency of 35%, the fuel cell efficiency may exceed 70%, making the Recuper technology 2.5 times more effective. The generated energy can be supplied to the pneumatic transport, water supply and sewage systems, heating systems for houses, schools, and medical institutions, or used for cryptocurrency mining. Besides, this energy can be used to heat pavements in the cities, to save the budget assigned to snow and ice removal, purchase of sand and de-icing reagents. Producing energy with this technology means a complete rejection of landfill and dumping sites or refilled local garbage containers. This causes an inevitable reduction of the utility fees for the population. We create an environmentally friendly future for us and our children. Waste makes energy. Recuper technology.